So let us deal with Z5 first. The members of Z5 as you are watching, wait a minute. No. Okay, so members of Z5 are 0 to 4 as you are watching. What the question is saying, let us see the wording once again. Find all generators of the cyclic multiplicative group of units. So we have to go with multiplication, we have to go with Z5. So you can see this is our Z5. I have talked about the multiplication over here. Modulo 5, of course. So 0 multiplied to any number is a 0. 1 multiplied to any number gives the same kind of thing, vertically and horizontally. Now let us talk about 2 2s are 4, 2 3s are 1, 2 4s are 3. Same kind of 3 1s are 3, 3 2s are 1, 3 3s are 4, 3 4s are 2. I hope all of you agree and you could recall it. Recalled it? Is it okay? Did you get the table what I have written over there? Okay. Okay. So what I observe here, I want to talk about cyclic group. So I have to talk about the powers of that element. If I take power of 1, what I'll get? 1 raised to 1 is 1. 1 raised to 2 is again 1. 1 cube is 1 and so on. So no need to talk about 1. So let us go to 2. 2 raised to 1 is 2. 2 square will be 4. 2 cube means 2 into 2 into 2, meaning 2 square into 2. 4 2s are. I search for 4 2s are. That is 3. I suppose you are getting it. Then if I go to 2 raised to 4, will mean that 2 cube into 2. So 3 into 2, it generates 1. So what you observe, all unit elements are generated here. What are the unit elements? Those which are invertible elements, only those. So you can see 1, 2, 3 and 4, all of them, they are unit elements because they are invertible. The answer comes out to be 1 somewhere. So they are unit elements. So what you observe? The group generated by 2 is simply non-zero elements of Z5. They are non-zero elements of Z5. So we denote it by Z5 star. Followed me? Okay,
Yes.
Okay, what do you mean by a cyclic group? If I say my group is generated by A, what I mean by this? Group generated by A. So it is the set of all powers of A. And what are those powers taken from? They are taken from
Integers.
Z plus. Yes, positive integers. They are taken from Z plus. This is what you have. So that is what we have shown. The powers of 2. They constitute of all unit elements of Z5. Only 0 is not unit, we know. So never we think of 0 as a unit. Okay. Now let me try with 3. You can see 3 raised to 1 is 3. 3 square. 3 3s are 9. 9 means 4. Then 3 cube. 3 cube means 3 square into 3. 4 3s are 12. 12 leaves 2. And lastly, 3 raised to 4 is 3 cube into 3. So 2 3s are. I got 1. Hello? So here again, all the elements are generated from Z5 star. So the group generated by 3 is nothing but Z5 star. Okay.
Yes, ma'am.
All right. Now, if I deal with element 4, what do you watch? 4 raised to 1 is 4, 4 square is 1. Again, 4 cube is 4, 4 raised to 4 is 1. So the elements 2 and 3 are never generated by 4. So 4 cannot be called as generator. So what are the possible generators you have? Only 2 and 3. So I now got it. The generators are only 2 and 3. Followed? Are we there? Let me repeat it, the same kind of thing. I just chose one element out of the set. I tried to find out the powers of that particular element. Once all the elements are generated, I say that particular element is a generator. And how do we write it? We write it in angular bracket. So this set Z5 star, Z5 star means non-zero elements in this particular case. So what it is giving me, 2 raised to 4 is my first non-zero element, 1. Second element is 2, that can be written as 2 raised to 1. Third element is 3, that can be written as 2 cube. And last element is 4, that I can write as 2 square. Did you follow me? I covered all the elements. So I can say this group is generated by 2. Followed now? Okay. Suvarna, are you getting me?
Yes, ma'am.
Okay. Now, if I talk about generated by 3, then what are the elements? Generated by 3. I get 3 raised to 4 as 1. Then 3 square, I'm sorry, 3 raised to 4 as 1. Then I want 2. So I can write as 3 cube. I want 3. So it is 3 raised to 1. And have to get 4 by squaring R3. So suppose you got me. I've written in order. So all the elements are generated. So I can say 3 is also generator of Z5 star. Generator of Z5 star. So what are the generators of Z5? 2 and 3 only, not 4. Hope so. Okay.
Yes, ma'am.
Okay. Now I would like to proceed with the next example. You can continue with Z7 same way. Then Z17 and Z23, they are big, little big, but you have to go with them. So I hope you'll try with Z7, Z17 and Z23 on your own. Now, I would like to proceed with this particular. So what do you observe here? X square minus 8, x square plus 8x minus 2 is irreducible over Q. Is this polynomial irreducible over R and over C also? So let us see whether this has that answer. If so, it will be easy for me to demonstrate. No. Okay, let us not waste time here. Okay, so we are back with our question. Yeah. So we are dealing with x square plus 8x minus 2. So what do you think? What will be the factorization? Here we are not in Zn kind of thing. We are directly in our Q. So if we are in Q, we need to think of Z as we have already done. So we will think of factors in Z. So what are the factors of -2? Factors of -2 are -2, -1, 1 and 2 only. Now you calculate the value of f of x for those. So what are the values of f of x for those? Huh? I hope you'll try. If I put -2 square is 4, -16. 4 minus 16 produces -12, -2, it gives me -14. Am I right? Am I correct? Okay. Then I put x equal to -1. So this becomes 1 -8 -2. That gives me -9. Still not a 0. I go with 1. 1 plus 8, 9 minus 2 produces a 7. And if I go with 2, 2 square is 4 plus 16, 20. 20 minus 2 is, so nowhere I'm getting a 0. So this is not irreducible over Q. This is not irreducible over Q. Are you noting down? Suppose you are noting down. So what you observe, this polynomial is not irreducible over Q. Now the question says whether it is irreducible over R. Do you have any factor of this? So whenever we are dealing with real numbers or complex numbers, we can factorize it what way? Minus b plus minus under root. I hope you know the formula. What is it? B square
-4ac.
So minus minus will be plus. 4 2 is 8. So what do I have? 72, root 72 and upon 2. So what is the value? -4 plus minus. This was 72. Factorization of 72. Yeah. Anybody? Factorization of 72. I want square factorization. So what will happen? 2 into 4 into 9. So out of root we'll have 6. Divided by 2, it will generate 3. So this will be 3 root 2. What kind of answer you have got? What is this answer? Whether it is rational or real or complex. Come on. Yes. What kind of answer we are getting? Is it rational first of all? Is root 2 rational?
No.
No. So this is not a rational answer. That is why we said it is not irreducible over Q. Is it irreducible over R? That we are answering. Is this a real number? Yes, because this is irrational. This is rational. Their combination we call a surd. And surd is a real number. This is a real number. So this is irreducible. I mean, this can be factorized. This can be factorized over R. So this is reducible over R. This is reducible over R. but not over Q. It is irreducible over Q. Not reducible means it is irreducible. Okay. And what about over C? So R is a subset of C. R is subset of C. If you are saying it happens in R means it has happened in C itself. So it is reducible in C also. I hope you are writing the answer. Please write this as f of x has no zero in Z. So it has no root. I mean, it has no factors in Q of x. But factorization is possible in R, and the factors are -4 plus -3 root 2. So f of x is reducible over R, can be factorized in R of x. And if it can be factorized in R of x, naturally it can be factorized in C of x also. You can read this as a complex number. What is this complex number? Yes, can you read this as a complex number? Plus I times 0. Can't you?
Yes.
So this is a complex root also. So if it is reducible over R, automatically it becomes reducible over complex. Followed the answer?
Yes, ma'am.
Okay. All right. So hope this is now familiar to you and you can solve all kind of questions here. All the questions that are visible here, you can solve. You have this page with you. Okay. So with this, I would like to stop